So hello students, today we see some important problems in stoichiometry. So first see, metallic tin. So the metal tin means Sn, we know that. Metallic tin is oxidized to its maximum oxidation state by potassium permanganate and potassium dichromate separately. It is in presence of HCl, mainly it is given acidic medium. In terms of HCl indicates the reaction taking place in acidic medium. We have to calculate the ratio of the values of decimolar. So here important. So what do you mean by decimolar? So decimolar means its concentration is given as 0.1 m. So decimolar means 0.1 molarity. If it is given decinormal, that's called 0.1 normality. Deci indicates 0.1. We know that. Solutions of potassium permanganate and potassium dichromate that would be reduced by 1 gram of tin. So already we know potassium permanganate, potassium dichromate are good oxidizing agents. So oxidizing agents ante the oxidizes other compounds. So manaki ee problem lo the oxidizes the potassium permanganate, potassium dichromate. Both oxidizes separately to the tin, metal tin, into its maximum oxidation. Maximum oxidation number means there is two possibilities are there for. So tin can be changed into Sn plus 2 or Sn plus 4 means tin is having two possibilities, Sn plus 2 stannous, Sn plus 4 stannic. So it is given it is oxidized by potassium permanganate and potassium dichromate separately to its maximum oxidation state. Maximum oxidation state we have to take Sn plus 4. So means it is given Sn is changed to Sn plus 4. So potassium permanganate, potassium dichromate works as good oxidizing agent. Itself they are reduced. So what is reducing agent? Tin works as the reducing agent because tin oxidize ayindante it works as a reducing agent. Tin reduces this potassium permanganate and potassium dichromate. So simple, potassium permanganate dichromate tin oxidize chestunnayante tin automatically obviously reduces this potassium permanganate and potassium dichromate. So ఇప్పుడు మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే 1 gram of tin reduces how much volume? We have to find the volume of potassium permanganate. The volume of 0.1 m potassium permanganate reduced by 1 gram of tin, and the volume of 0.1 m potassium dichromate, which is again reduced by 1 gram of tin. And actually two problems. This 1 gram of tin toni enta potassium permanganate reduce avutundi dan value find out cheyali. So this 1 gram of tin toni how much volume of potassium dichromate reduce avutundi adi find out cheyali. So already manam volume ratio find out cheyali. Only the ratio of we have to find the ratio of values of decimolar solutions of KMnO4 and K2Cr2O7 which are reduced by 1 gram of tin. Okay, so first we see about so మనం separate the reaction ఇచ్చింది కాబట్టి two problems మనం separate గా చేయాలి. So first ఈ 1 gram తోని ఎంత వాల్యూమ్ ఆఫ్ పొటాషియం పర్మాంగనేట్ రెడ్యూస్ అవుతుంది అది సెపరేట్ గా క్యాలిక్యులేట్ చేస్తాం. సో నెక్స్ట్ 1 gram ఆఫ్ టిన్ తోని ఎంత పొటాషియం డైక్రోమేట్ వాల్యూమ్ రెడ్యూస్ అవుతుంది. we do it separately. Okay, so first we have to calculate the n factor. సో ఎట్లా మనం ఈ ఈక్వల్స్ ఈక్వల్ చేయాలి కాబట్టి so we have to know about n factors. So all are known compounds. Here when it is given Sn becomes Sn plus 4. When it is possible? By losing 4 electrons. So n factor for tin is equal to 4. So here we are taking first case. We are taking potassium permanganate, and we know that potassium permanganate MnO4 minus changed to Mn plus 2. Here oxidation number of manganese is 7. So by taking 5 electrons, we know the n factor is equal to 5. The first one tin ki permanganate ki reaction ki మనం problem చేస్తున్నాం. Okay. So milli equivalents of the milli equivalents of tin, milli equivalents of tin are exactly equal to milli equivalents of MnO4 minus. So milli equivalents mean we know that normality into, so general we know, so normality into its value, normality into its value. Now we can take N1 V1 equal N2 V2. So just remember the n factor values. Okay. See. So what is the normality? So in question, is there any normality is given for equivalent? No, nothing normality is given. But so we know that normality మనం ఎట్లా calculate చేస్తాం? weight by equivalent weight, we know that. So ఇక్కడ నేను expand చేద్దాం. Weight by gram equivalent weight into 1000 by value in milliliter. Again its value will be milliliter. So same thing, same value. Then milli equivalents of MnO4 minus. If there is any information is given, it is given only molarity. So molarity is given. It is given decimolar. Decimolar, that is 0.1 molarity. So normality equal molarity into n factor. What is n factor for it? 5. We have to find the value of this MnO4 minus. Okay, molarity into n factor into value. So here VV get cancelled. Okay, what is the weight? So weight of tin is given 1 gram. What is the gram equivalent weight? So here gram equivalent weight of element. Actually it is the first problem. So మన gram equivalent ఎప్పుడైనా oxidizing agent, reducing agent, so different compounds కి వచ్చింది. ఇక్కడ కూడా it works as reducing agent. నార్మల్ గా కి ఎలిమెంట్ ఫార్మ్ లో తీసుకోవచ్చు. సో ఎలిమెంట్ ఫార్మ్ లో తీసుకుంటే there is a confusion that it may be having +2 oxidation number, +4 oxidation number. సో ఇక్కడ మనం n factor అని తీసుకోవాలి 4 because n factor 4 కాబట్టి. So why you are discussing about that? And the gram equivalent weight means molecular weight. Actually molecular weight ఇక్కడ metal కాబట్టి we have to take atomic weight. So what is atomic weight is given? So in the problem it is given 118.6. Generally మనం 118.5 తీసుకుంటాం, but particularly in this problem it is given 118.6. What is n factor? Value of MnO4 minus. So actually V milliliter. Our target is calculate the value of potassium permanganate. So how you will get it? The 4 into, so write it as 10⁻³ okay. So 0.1 into 5 means 0.5. Okay. So finally we can write so V milliliters 0.5 can add 1/2. Okay. So 1/2 become 8. So just take it as equation 1. So there is no need to calculate the total calculation. But total calculation అవసరం లేదు, because మనకి వాల్యూమ్ ఆఫ్ పొటాషియం పర్మాంగనేట్ నెక్స్ట్ వాల్యూమ్ ఆఫ్ పొటాషియం డైక్రోమైడ్ ఎట్లా రేషియో ఫైండ్ అవుట్ చేస్తాం కాబట్టి సో టోటల్ క్యాలిక్యులేషన్ కి మనకి టైం వేస్ట్ అవసరం లేదు. సో జస్ట్ రిమెంబర్ దిస్ వాల్యూ 18 to 10 power. So I am writing that value here. That is 18 to 10 power 3 by 118.6. So this is the equation 1. Next we do the problem with the potassium dichromate, that is case 2. So what is the case 2? Say in the case 2, here we are doing the calculation in case 2, that is a reaction of tin with potassium dichromate. So we don't know the exact reaction, but we know there is no required to know the reaction. Simply we can equalize the milli equivalence. So milli equivalence of tin is exactly equal. Exactly equal means the reaction, when a reaction takes place, their milli equivalence compulsory equals. The milli equivalence of potassium dichromate, the change in the part is Cr2O7 minus 2. So we know that it's n factor for tin. So Sn gives Sn plus 4. Here n value 4. What is the dichromate? Cr2O7 minus 2, it becomes Cr plus 3. So I have to remember this chain because in many problems we got this. Here each chromium having plus 6 oxidation number. Here each chromium has plus 3. So plus 6 to plus 3 one chromium. Second chromium also plus 6 to plus 3. So total 6 electrons. Okay, means here n factor is equal to 6. N factor equals 6. So మనం ఇప్పుడు ఇది ఫాలో అవుదాం milli equivalence of so milli equivalence means say normality into volume equals normal. So the normality, again we know that I am not expanding this. So normality just now we written the formula, weight by gram equivalent weight into 1000 by V. So what is the weight? 1 gram. What is the atomic weight? So మన metals కాబట్టి single element కాబట్టి we are taking atomic weight. If it is any compound we take as molecular weight. Okay, atoms కి మనం atomic weight తీసుకుంటాం. Metal అంటే nothing but is a form of atom కాబట్టి then atomic weight తీసుకోవాలి. Not a single atom, it is the element name is given, so we are taking atomic weight, that is 118.6 gram equivalent weight and by n factor into 10 power 3 by value in milliliter. This is the normality formula. Again into value put it milliliters. Milli equivalence it must be milliliters. So you can normality it is given, normality it is also decimolar. Decimolar means 0.1 molarity into n factor become normality. We have to find the value. So here we value get cancelled. So finally volume of potassium dichromate is how much? 4 into here we can write 0.6. So don't do any calculation. Say it is equation 2. So actually what is the problem means we have to find the ratio, not exact value. Just in the question it is given that calculate the ratio of the values. So equation 1 lo the what is that volume of potassium permanganate which is reduced by 1 gram of tin. So it is in the equation 2, in the case 2 we done the value of potassium dichromate reduced by say this 1 gram of tin. So in all problems we are using the same formula, but there are with some modifications. So try to practice yesterday's problems also. So that's why we are giving just 4 to 5 problems per day. So therefore we can write the ratio. So therefore from equation 1 by 2, the value of potassium permanganate by value of, so what was the equation 1? So I written on this paper. So that is 8 into 10 power 3 by 1 by 0.6 into what is the equation 2. So by means we can take like this. Total we are getting a 0.6 into 2, which is approximately 0.12. That is a 1.2 by 1. So the ratio is 1.2 by 1. Or we can say it's a 12 by 10. Or in other terms, we can write 2 6 2 5. It can be written as 6:5. So as it depends on the given option, general in multiple choice questions. Okay, so the final answer is 6:5. See one more different problem. So here, upon heating 1 liter of 2N means normality of HCl solution. So if the initial solution is 1 liter of 2N HCl, on heating what happened? 36.5 grams of HCl is lost and the volume of solution reduced to 800 milliliter. At starting with 1 liter 2N HCl solution. So what is the initial solution? And 1 liter of 2 normality HCl solution. It is heated up to some temperature and for some time it is not given. So so after overall heating, the amount present in that solution loses 36.5 grams. And that amount of 36.5 grams of HCl is lost and the volume of solution reduces to 800 milliliter. That HCl percentage poindi. Next, so volume also reduced. Volume enta decrease 1 liter at 1000 milliliter. Okay, so it is reduced to 800 milliliter. So it might be a given condition. But what is the problem is to calculate the normality of final solution. What is the final solution? So normality initial solution given as a 2 normality. But the value is 1 liter solution. 1 liter solution is 2 normality. That amount of HCl. But after some time, heat చేసిన తర్వాత అక్కడ 36.5 grams వెళ్ళిపోయింది. 36.5 grams of HCl వెళ్ళిపోయింది. So value will change to 100 milliliter. So కాబట్టి 800 milliliter is the final solution. ఈ final solution కి normality find out చేయాలి. First we write the normality. Okay. Normality formula use చేద్దాం. So we know the general formula of normality, it's weight by gram equivalent weight into 1000 by volume in milliliters. So it is equation 1. The main problem is what is the volume? So volume of the final solution is 800 milliliters. No problem. But the problem is what is the weight? So gram equivalent weight, and we know that gram equivalent weight of acid find out this term. Its molecular weight by its basicity. HCl కాబట్టి 36.5 by 1. So అట్లా చేసేస్తాం. So but we don't know the weight. So weight initial weight తెలియదు మనకు అసలు ఫస్ట్. Initial weight తెలిస్తే సో దాంట్లో ఎంత లాస్ అయింది ఆఫ్టర్ హీటింగ్ 36.5 grams of HCl లాస్ అయింది. సో ఫైనల్ ఎంత రిమైనింగ్ మనం ఫైండ్ అవుట్ చేయొచ్చు. 800 milliliter ఎంత HCl ఉందో we are able to find out if you know the initial weight. సో ఇనీషియల్ వెయిట్ ఫైండ్ అవుట్ చేయడానికి అగైన్ వీ హ్యావ్ టు డూ అనదర్ స్టెప్. సో ఇది మనకి యాక్చువల్ మనం ఫైండ్ అవుట్ చేయాల్సింది ఇది నార్మాలిటీ ఆఫ్ ఇది 800 milliliter. వి నో ద వాల్యూ. ఓకే, సో దీనికి okay, I am writing the expansion for this. Normality equal to weight by we don't know the weight. Gram equivalent weight means atomic weight by valency. Sorry, ikkada axis not basicity 1000 by 800 milliliter. So direct గా చేయొచ్చు, బట్ ఇఫ్ యూ నో ద వెయిట్, సో నీకు ఫైనల్ సొల్యూషన్ లో వీ డోంట్ నో ద వెయిట్, జస్ట్ దాని ఈక్వేషన్ 1 వదిలేయండి. ఓకే, సో మనం సపరేట్ గా అసలు స్టార్టింగ్ లో ఎంత వెయిట్ ఉందో ఫైండ్ అవుట్ చేద్దాం. ఓకే, సో క్యాలిక్యులేటింగ్ ఇనీషియల్ వెయిట్ ఆఫ్ HCl. So initial weight find out data. So initial weight find out data is very simple. You know the normality telsu, value telsu. So normality equals same formula, but ikkada liters undi kabatti normality equals weight by gram equivalent weight into 1 by value in liters. So normality addition to 2 normality weight equals 6.5 by 1. Ikkada 1 liter get cancelled. So what is the initial weight? Initial weight equal 2 into 36.5. Okay, this is 73 gram. Initial weight is 73 gram. So దాంట్లో ఎంత లెఫ్ట్ అయిపోయింది? 36.5 gram లెఫ్ట్ అయిపోయింది. ఇంకా రిమైనింగ్ ఎంత? సరే 36.5. అంటే నీకు ఫైనల్ 800 milliliter సొల్యూషన్ లో హౌ మచ్ HCl is present? 36.5 is present. సో దానికోసం మనం ఇనీషియల్ గా ఎంత HCl వెయిట్ ఉందో ఫైండ్ అవుట్ చేస్తాం with the help of this formula. సో ఇనీషియల్ వెయిట్ ఫైండ్ అవుట్ చేసిన తర్వాత యాక్చువల్ మనం క్యాలిక్యులేట్ చేయాల్సింది ఫైనల్ సొల్యూషన్ కి, బట్ ఫైనల్ సొల్యూషన్ లో మనకు వెయిట్ ఆఫ్ HCl తెలియదు కాబట్టి with the help of the given details we find the weight of starting HCl, initial HCl. సో ఫైనల్ ఇక్కడ ఇంకో ఇన్ఫర్మేషన్ ఏమిచ్చిండు? 36.5 grams of HCl is lost. సో 36.5 grams of HCl lost కాబట్టి so given that 36.5 gram of HCl is lost, so on heat cheste finally given that 36.5 HCl lost item. So therefore weight of HCl in final 800 milliliter solution is equal to how much? 73 minus 36.5, so exactly 36.5 grams. Okay, so mali again go to equation 1, means 800 milliliter manaki weight తెలిసిపోయింది. So from equation 1 we can write the normal weight is how much? 36.5. What is the equivalent weight? You know, already we done it. Okay, so by 10 mean how much you are getting? So 1.25. So the normality of the final solution is 1.25 normality. అంటే 800 ml after complete heat అయిపోయిన తర్వాత సో రిమైనింగ్ ఉన్న 800 milliliter సొల్యూషన్ కి నార్మాలిటీ ఏంటంటే 1.25 నార్మాలిటీ. ఓకే, నెక్స్ట్ ఇదే ప్రాబ్లం లో అగైన్ వాట్ వాస్ ద అనదర్ క్వశ్చన్? సో అండ్ ఆల్సో ఫైండ్ ద ఈక్వివలెన్స్. అండ్ వాట్ వాస్ ద క్వశ్చన్? So and also find the number of equivalents of HCl of initial solution if you take 100 milliliter of solution. So we have to find in the same problem. The question is the number of equivalents. Okay, it is the next total next. So it's a second problem actually. So what is the general formula for number of equivalents? So we know that number of equivalents means normality into volume in milliliter. So you can find out chance in the initial solution. So initial HCl solution. So initial normality is given how much? 2. Initial normality is 2. But actually the initial volume into 1 liter only. 1 liter and 1000 ml. But 1000 ml can find out it is the question is find it for 1000 ml. Sorry. Find it for 100 milliliter 100. So therefore, for 100 milliliter of HCl solution, number of equivalents equals simple. V milliliters, how much milliliter? Just normality is given how much normality. So value is given for how much? How much value is given? So calculate HCl for 100 milliliter of solution. So for 100 milliliter of solution it becomes how much? Number of equivalents normality and what is the value? Okay, so number of equivalents for 100 milliliter solution. So that is normality into its value. So that is 200 equivalents. So in the question it is given that find the milli equivalents. So the number of equivalents, okay, the number of equivalents equals 200 equivalents. Okay. So here, so what we done is number of equivalents, but we given the formula normality into value in milliliter. Actually, so what is the normality into value in milliliter? That is number of milli equivalents. Sorry. So it is the formula for number of milli equivalents. So and we know the formula for number of milli equivalents. Number of milli equivalents is equal to 200 milli equivalents. I think in the question it is asked that find the number of equivalents. So milli equivalents is correct. Therefore, number of equivalents. Number of equivalents means by 1000. So 0.2 equivalents. So actually I need to value in milliliter. We know that is a number of milli equivalents. Milli equivalents chestam. So mana direct the channel direct equivalents ante normality into value in liters. Normality into value in liters. So direct we will get equivalents. So I'll just do that also. So the problem is completed. So just I am writing in another mode, that is so number of equivalents equal to normality into value in liters. Actually equivalents milli equivalents and value in milliliters. Number of just equivalents and normality into value in liters. What is the normality? 2. What is the value? 100 milliliter. So convert into liters. So we know that by 1000. So finally we get the same thing. That is 0. Equivalents. So it's very simple one step like that. Okay. Okay, we do some more problems in the next class. First try one more problem. So try to do these problems. Actually we are not sending any separate worksheet for these problems. Okay, so try to do this problem. So why you are not sending any separate worksheet for these problems is because one problem there is some variations are there. In each problem there is some variations are there, so it may become problematic to calculate by you. So you may try to left the problems, or you may try to take the answer from others. So that's why these are very important models. That's why we are discussing in the class only. Okay, so take the problem.